I close my eyes, the system will automatically detect the change in E aspect ratio.
Wake up, sir. 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 Wake up, sir.
I will start yawning.
Take some fresh air, sir. Take some fresh air, sir. Wake up, sir. Wake up, sir.
I will be explaining the codes now. I have imported these packages, which allows me to use functions from those libraries in order to determine if I'm drowsy or not. Before proceeding to the main program, I'll explain the functions first. We have the alarm function. In this function, we are using the OS command espeak to tell text loud to the user. The alarm takes as parameter a message which will be provided later in the program, and the function will say it out loud to the user. The espeak is a package installed in the Linux itself. It is not a direct package of Python. This is why we are using os.system, where I'm passing the message in it. It is a system command, that's why this function is being used. This program mainly deals with I aspect ratio, and therefore in the function final I aspect ratio, we find the coordinates of the left and right eye in a landmark file. We then pass those values to the I aspect ratio function, which I will go later, and then to the main program we will return the I aspect ratio for both the left and right ears, and then we'll do an average of them. We proceed to the I aspect ratio function. It calculates the Euclidean distance between several points in the eyes, and we use those distance to calculate the aspect ratio of the eye. In our eye there are several points of interest where we can use them to calculate the length of diagonals between those points. This is why for each eye we are using these three distances, and then making an approximate value of the I aspect ratio using this mathematical equation. In the lip distance function, we will be measuring the distance between the top lip and the bottom lip in order to determine how much the user is yawning. Again, as before, there is a landmark file which contains the coordinates of the lip, and therefore I'm accessing those coordinates here. We now proceed to the main program. We use the webcam as input for our video, and then we initialize all the thresholds needed to determine if a user is drowsy. We have variables to detect the status of alarms. We will be using the Cascade classifier from the OpenCV library. It is a machine learning tool where the Cascade function is trained from lots of positive and negative images and then used to detect objects in other images. In our case, the object involved is a front face. This is why the Cascade frontal face file is used. There are several of those files for Cascade, and we chose this one because it corresponds exactly to the features we want, that is, identify landmarks on our face. We then use a shape predictor from the dlib library. It is used to localize individual features such as eyes, mouth, and nose, or even jawline. We give as parameters a landmarks file containing the coordinates of the different features on the face. Then we start reading each frame from the webcam, as seen by the read function. We then resize the frame and convert it to grayscale because it is easier to work with grayscale. With color images, there will be more processing to be done. The function detect multi-scale detects faces and returns the positions of the detected face in an array. This function will take the frame and find a rectangle where we can have the whole face in it. We then iterate through the list of rectangles obtained. Hopefully in this question only one, because there is only one face. We then generate the rectangles and convert it to NumPy arrays. We then pass it to the final eye aspect ratio function which we saw earlier, as well as to the lib distance function. Those functions are returning us the values of the eye aspect ratio as seen here. Using the coordinates obtained, we then draw the contours of the eye and mouth on the frame. And now we go to the main logic of the system. If the eye aspect ratio is lower than the threshold for eye aspect ratio that we initialized before, we increase the counter by 1. If the counter becomes greater than the number of consecutive frames that we are monitoring, then we trigger the alarm. However, we did not use the alarm in the main thread of the system itself. We used a second thread in order not to pause the execution of the program while the audio is being played. If we had used all its codes in the same program itself, while the audio is playing, the system would no longer monitor the drowsiness of the user, and therefore we would be losing some data while the audio is being played. As we can see here, the system will read out loud "wake up sir" for the user, and then on the frame it will put a text saying that it detected drowsiness alert. Else, if the number of consecutive frames have not been reached, the counter is reset to 0 and the alarm becomes false. We repeat the procedure for the yawn threshold, that is, to see if the user is yawning too much. If yawn is detected, again the system will put a text on the frame saying that there is a yawn alert. And again we read the text out loud for the user. In this case, take some fresh air, sir. The following lines of code will always display the eye aspect ratio and the yawn ratio on the frame itself for every frame. And then when we press the Q button, the system stops running.